Good morning, sir. My name is Meghannath. I'm from ECA B section. I'm here to say about my TED Talk topic. My TED Talk topic is about waves and forms. What is a wave? A wave is a disturbance that moves energy from one place to another. Only energy, not matter, is transferred as a wave moves. The substance that a wave moves through is called as a medium. The medium moves back and forth repeatedly, returning to its original position. But the wave travels along the medium. This picture represents the wave, example of a wave. Types of a wave. There are three types of waves. They are mechanical waves, electromagnetic waves, matter waves. So coming to mechanical waves, a mechanical wave is a wave that is an oscillation of matter and is responsible for the transfer of transfer of energy through a medium. So this picture represents the example of a mechanical wave and electromagnetic waves. Electromagnetic waves are members of the family of waves with common properties called the electromagnetic spectrum. And this picture represents the electromagnetic waves, matter waves. The set of waves that represent the behavior of an elementary particle or from atoms and molecules under certain conditions are called matter waves. And this picture represents the matter waves. Waveforms. Waves travel in two different forms. Transverse waves are waves in which the energy that is transmitted oscillates perpendicular to the to the direct to the direction the wave is traveling. Longitudinal waves are waves in which the energy that is transmitted oscillates parallel to the direction the wave is traveling. So these are the two types of waves. One is transverse waves and another one is longitudinal waves. And these two represent the definition of transverse waves and longitudinal waves. This picture represents the longitudinal waves and transverse waves. As we see in longitudinal waves, there are many number of oscillations, and when compared to transverse waves, there are very less number of oscillations. Parts of waves. This slide represents the parts of waves. So there are totally four types of parts of a wave. They are wave crest, wave crest, the highest part of a wave. So in this picture, we can see the wave crest here. As we can see the highest part of a wave, which represents as the wave crest. And coming to the next point, the wave trough, the lowest part of a wave. So in this picture, we can see the lowest part of a wave when the wave is formed. So this lowest part is called as wave trough. Wave crest is known as the highest part of a wave, and the wave crest is the lowest part of a wave here. Wave height, the vertical distance between the wave trough and the wave crest. So wave height in this picture we can see the wave height clearly. The height of a wave crest and wave trough medium. The distance between the wave crest and wave trough, as the wave crest is the highest part and the wave trough is the lowest part. The Distance between the wave crest and the wave trough is known as wave height. And the next point is wavelength. The distance between the two consecutive wave crests or between two consecutive wave troughs. So wavelength is nothing but the distance between two consecutive wave crests or between two consecutive wave troughs. So in this picture we can see the wavelength of a given wave. So here it is the distance from the two consecutive wave crests or as well as wave troughs. So the distance between the two consecutive wave crests or between the two consecutive wave troughs is known as the wavelength of a wave. So these are the four types of major parts of a wave, which we can understand clearly as shown in the below picture. Frequency and wavelength of waves. The shorter the wavelength, the higher the frequency. This slide shows us the frequency and wavelength of a wave. The shorter the wavelength, the higher the frequency. Hence, frequency and wavelength are inversely proportional to each other. Because all light waves moves at the same speed in a vacuum, the number of wave crests passing at a given spot with one second is determined by the wavelength. So, as we know that the shorter the wavelength, the higher the frequency, and those the shorter if the wavelength is shorter than the higher of the frequency, then it is inversely proportional. Or else we can also assume that the higher of the wavelength and the lower the frequency, it also defined as the inversely proportional to each other. Because all light waves are moved at same speed in a vacuum, the number of wave crests passing at a given spot is 1 second is defined by the wavelength. So this picture represents the wavelength, frequency and wavelength of a wave. So in the above one, in the above frequency line, we can see that the number of frequencies are higher in number than the wavelength. So as the wavelength is very close, the number of frequencies are very high. As the wavelength is very long, number of frequency lines are very shorter. So by this picture, we can also say that these both are inversely proportional to each other. So wave speed. Wave speed is the distance. Wave speed is the distance a wave travels in a given amount of time, such as the number of meters it travels per second. Wave speed is related to wavelength and wave frequency by equation. Speed is equals to wavelength into frequency. This equation can be used to calculate wave speed when wavelength and frequency are known. So this slide represents the wave speed, and we can see that how can the wave speed can be calculated, as we know that the number of meters it travel per second, and the formula is speed is equals to wavelength into frequency. So to determine the wave speed, we need to have the values of wavelength as well as frequency to calculate in the given formula. So these two pictures represent the formula as speed is equals to wavelength into time. So this triangular picture represents the frequency speed as meter per second, frequency as hertz per Hz, wavelength as lambda. And coming to the next slide. superpositions of waves. The superposition principle states that when two or more waves overlap in space, the resultant disturbance is equal to the algebraic sum of the individual disturbances. So the superposition of waves can be understood by observing this picture. As we see that one wave is overlapping the other wave within the space. So this phenomenon is known as superposition of waves. The superposition principle states that when two or more waves overlap in space, the resultant disturbance is equal to the algebraic sum of the individual disturbances. So this picture represents the superposition of the waves. And coming to the last slide, interference of a wave. Wave interference is the phenomenon that occurs when two waves meet while traveling along the same medium. The interference of waves causes the medium to take on a shape that results from the net effect of the two individual waves opposite particle of the medium. So in this picture we can see that the interference of a waves. As wave interference is a phenomenon that occurs when two waves meet while traveling along the same medium. The interference of waves causes the medium to take a shape that results from the net effect of two individual waves upon the particle of the medium. As we know that if a wave overlaps with the another wave in the same medium, then it is called an interference of waves in a medium. Thank you, sir.